In this part of our report, we will be talking about how nanobiotechnology is being used to address some of the most pressing problems in water quality and medical research. We'll also look at the current trends and global investments driving this fast and growing field. Let's start first with how nanotechnology is being used to help water pollution problems. First, removing industrial contaminants from groundwater. Nanoparticles can actually convert harmful chemicals into harmless ones through a chemical reaction. What's great about this approach is that it works in deep underground settings where pollutants are hard to reach, and it's much cheaper than pumping water up to the surface for treatment. As we know, traditional desalination methods can be expensive and energy extensive, but now scientists are also experimenting with electrodes made of nano-sized fibers that can deionize water more efficiently, meaning we can turn salt water into drinking water at a lower cost and lesser energy input. Nanobiotech is also being used to filter out viruses in waters. Normal filters can catch viruses since they are too small. However, nanoscale filters, which are only a few nanometers wide, are being developed to remove viruses and make water safer for human consumption. So, nanotechnology is making water purification faster, cheaper, and more effective than ever. Current research trends for nanobiotechnology is extensively being studied in fields of nanomedicine and nanomaterial development. One major focus on medical applications is disease detection and treatment. Diseases like cancer, Parkinson's, and Alzheimer's are hard to treat because they're often detected too late. Nanotechnology allows scientists to identify biomarkers much earlier than before. And biomarkers are tiny molecular signatures of the disease that we are trying to look for. A great example of this scenario is the biobarcode assay. This method uses gold nanoparticles to detect proteins or DNA linked to diseases. For Alzheimer's disease, it can identify molecules called ADDLs, and it's 1,000,000 times more sensitive than current diagnostic measures. Another area of or field that is being studied is the fabrication of nanoscale materials. Researchers are taking inspiration from nature, using diatoms, cells, and viruses to build or assemble nanostructures. For example, diatoms can now be converted into ceramic nanoparticles. For bacteria, some have been engineered to produce magnetic nanoparticles coated with proteins. And on the other hand, viruses assembled battery also exist, where viruses are engineered as well as scaffolds for growing semiconductor nanoparticles. Let's now talk about funding and global support. Nanotechnology has the potential to transform economies and improve living standards. However, many major applications are still 5 to 10 years away, so continued research and development are essential in this field. Because private investors usually want quick returns, government support plays an important role in funding early-stage research in nanoparticles. For example, in the United States, government funding for nanotechnology grew from $464 million in 2001 to $1.5 billion in 2009. And also, the private industry is then matching that investment. In other nations, the European Union contributes about 1.05 billion, Japan contributes around 950 million, and countries like Korea, China, and Taiwan have invested hundreds of millions and more. This shows that nanotechnology is a global effort, with nations competing and collaborating to push scientific boundaries. In summary, nanotechnology is helping us clean water, detect diseases early, and create new materials that could change industries. And as we've seen, with strong research and investment, its impact on both the environment and human health will continue to grow in the coming years. Thank you for watching.